Thunderstorm. Thunderstorm. Up, 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 my thunderstorm. Thunderstorm. Up, 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 my thunderstorm.
NASA cameras captured these amazing images of our electric skies. Right at this very moment, there are almost 1,800 individual thunderstorms taking place around the planet. Lightning always looks like it comes from the sky, but that's only half the story. What you can't see is that the big flash is actually shooting up from the ground into the clouds in 1/10,000th of a second. And at 30,000 degrees Celsius, the bolt superheats the air around it, making it literally explode. That's the sound.
Generation of cameras has enabled scientists to record a strike that lasts just a fraction of a second and play it back over 200 times slower to analyze its detail. These super slow motion images show the stepped leader making a connection with the ground. The entire charge then drains from the cloud above, seen as a series of pulses. Using the latest camera technology, scientists are beginning to unravel the mysteries of lightning.
Coming fast. I do know thunderstorms are first and how the pressure is fed. In the spring, early summertime, where dry cold and warm once they are met. Like the cold of the one that will rise. Air mass and heat can cause a squall line in a place called the alley inside. Nebraska to Texas, y'all. So I know that when it touches down too high, the funnel shaped cloud is chasing me right overhead of me. The strike has destroyed everything in its path. It's like a whirlwind spinning over my head. It's like it won't stop till it rests where it's been. As a tornado shows its might.
Tornado Alley. Tornadoes pack the most powerful winds on our planet. Rotating at speeds up to 300 miles per hour, this is Mother Nature's greatest show on Earth. These whirlpools of wind are unimaginably powerful. And when they make contact with human beings, they become one of the most deadly forces on Earth.
tripped. Roofs coming off houses, mobile homes smashed to bits. F3 is severe, walls of homes come down. Taking trees right from the forest, yeah, let me see them fly. Oh yeah, F4 devastating when homes are mostly leveled and large missiles come by. F5 still concrete crack, frame houses are made to jump. Wet cars are picked up, they look like they shot out from a gun.
Tornado spinning wind, like a wizard. Cold dry air meets warm moist air, getting twisted, spinning, reaching to the sky when the airs mix. Now we measure up high to an F6, like an F6, like an F6. Now we measure up high to an F6.
The weakest twisters are called EF-Zeros. These tornadoes produce winds between 65 and 85 miles per hour. Although relatively weak, they still have the power to rip branches off trees and hurl lightweight debris through windows. Next on the scale is an EF1. These tornadoes create winds between 86 and 110 miles per hour. They can strip roofs from houses and overturn mobile homes. An EF2 tornado. It spins up to 135 miles per hour. This one in Oklahoma hurled heavy hay bales hundreds of yards and uprooted trees. An EF3. Winds inside these twisters can gain speed up to 165 miles per hour. The inside, or vortex, of a tornado this strong is full of flying wreckage on a lethal scale. This is what airborne objects traveling at 160 miles per hour will do to a car. Jagged pieces of steel, wood, and glass, propelled by violent tornadoes, are especially deadly. But this is still only halfway up the scale. An EF4 generates winds between 166 and 200 miles per hour. Cars are hurled like toys, and well-constructed houses completely leveled. The most powerful tornadoes in the world are EF5s. These twisters define the word monster, with winds known to exceed 300 miles per hour. The damage EF5 tornadoes wreak is beyond comprehension.
First, a structure is pounded by a blast from the base. Then, rotating winds go around the outside. And finally, like a boxer with an uppercut, a powerful upward draft finishes off the structure. There's more. Wind follows a simple rule. Once it gets into a building, it wants to get out.
The house is coming apart.
This means either blowing out the walls, the roof, or simply exploding the entire building.
Oh my God! Did you see that? The whole house was apart.
About once every 3 days, a pocket of superheated Saharan air breaks away from Africa and drifts over the Atlantic. These warm air pockets are called tropical waves. This hot air generates giant convection currents that drive moisture from the surface of the ocean high into the atmosphere. As this moisture-laden air cools, it begins to condense into bands of clouds. This is the beginning of a hurricane.
We're witnessing the passage of a tropical wave that started off the coast of Africa, migrating past us on its way to the Gulf of Mexico. And you're seeing here this very moisture-laden air rising. This is very typical of what happens in the convective cells inside these tropical waves.